Did the most powerful telescope ever launched into space prove to be worthy? Did the $10 million piece of technology bring in what it was expected to? Any guesses? Unravel the answer on your own, as we'll be taking a deep look at James Webb's latest findings of our universe. Can't wait anymore? Let's hop right in. If any of you guys aren't familiar with James Webb, it is NASA's space telescope primarily designed to conduct infrared astronomy. Development starting in 1996, the JWST was planned to be launched by 2007 with a $500 million budget, but there were many delays, including a major redesign in 2005 and other issues with the telescope that meant it finally launched on the 25th of December 2021 from ESA's launch site at French Guiana. James Webb was expected to enable a broad range of investigations in the field of cosmology and astronomy. Well, the JWST seems to live up to the expectations. NASA, one of the JWST's collaborators, along with the Canadian Space Agency, points out Webb as a successor to Hubble rather than a replacement. The James Webb is easing its way into its new home and has already sent in some of the most astonishing pictures of our galaxy, including the pictures of certain breathtaking nebulas. And its latest findings have shaken the entire space industry. Feeling pumped to know what is in these latest pictures and why everyone is in chaos about it? Where is the James Webb Space Telescope now? 3 mid-course correction maneuvers successfully placed the huge space telescope in a slow looping orbit around the second Lagrange point, a stable gravitational point 1.5 million kilometers behind Earth as seen from the Sun. The Hubble Space Telescope has not just brought in stunning images, but it's paved the way for exemplary advancements in our knowing of the universe. Since astrophysics wanted more advanced instruments to understand the workings of the universe better, the JWST was introduced. However, the JWST has less pointing flexibility than the Hubble Space Telescope. However, because of its far-flung location, the new telescope cannot be accessible once launched, making missions similar to the Hubble servicing missions impossible. Its launch was a much-anticipated event last year. The telescope's 6.5-meter diameter gold-coated beryllium primary mirror was so huge that it had to be broken into 18 segments to fit into the launch vehicle. Each hexagonal segment, fitted with 7 actuators, can be slightly tilted, shifted, deformed and rotated to ensure they operate together as one perfect parabolic surface. There were no chances for sending in humans to service the JWST, as it was millions of kilometers away from Earth. Fortunately, the telescope deployed itself in space without any faults. The signature heat shield, also folded during launch, unfolded easily. The launch and deployment of the JWST was a grand success that it saved so much fuel to almost double its lifetime in space. However, it will stop working once it runs out of fuel until the engineers find a way to refuel the telescope, which is 1 billion miles away from Earth. Since its development, NASA engineers have been working hard to set the telescope up, which is a Herculean process. Each part of the telescope needs to be calibrated and they have to be tested at each stage, which could take almost a month. The first image sent in by the JWST was the 18-star mosaic taken in February. In the initial images, the star was seen in 18 different positions as the mirrors were still in the alignment phase, which caused light to reflect into the telescope's instruments. When the near-infrared cam gets cold enough for its sensitive mercury-cadmium telluride detectors to pick up infrared light, the aligning process of the mirrors can finally commence. Pretty soon, JWST sent images of the same star, and the changes were quite evident. NASA completely focused the primary mirror of the JWST by the 11th of March, and the results were beyond all bounds and expectations. Soon the telescope was certified to capture focused images using 4 powerful onboard science instruments, and the JWST was moved to the final series of preparations known as the Science Instrument Commissioning. The images of J17554042 plus 651277, released on the 16th of March, had excellent precisions, providing that all the mirrors were accurately aligned, giving the telescope its honeycomb shape. This milestone marked an end to the procedure known as fine phasing. Furthermore, Webb's images will only become clearer and more detail-laden as its other 3 instruments arrive at their intended cryogenic operating temperatures. Thanks to its giant sun shield, the JWST has already reached -200 degrees Celsius by early January 2022. But the passive cooling slows down over time. The telescope's mirrors are now completely focused on light collected from space, and each instrument is successfully capturing images. The telescope's 3 imaging instruments include the near-infrared cam and the mid-infrared instrument. The 4th one is a spectrograph that can take images for target acquisitions. The NIR spec has a micro-shutter array of several 100,000 shutters that can be opened or shut to select which light is sent into the spectrograph. In addition, the fine guidance sensor tracks guide stars to train the observatory accurately and precisely. The image data can be used to assess image sharpness and calibrate subtle image distortions. Equipped with beam splitters and micro shutters, each has different observing modes that have to be fully tested and calibrated before they're handed over. Of course, every instrument has been tested and checked on Earth by Mark McCaughrean, the Senior Advisor for Science and Exploration at the European Space Agency, NASA's main partner in the program. The NIRCam is the observatory's wavefront sensor and a key imager, and it was chosen because it has a wide field of view and a unique capability to operate at higher temperatures safely. The Optical Telescope Element Manager for the JWST, Lee Feinberg, claimed that the images showed what people from different backgrounds working together could achieve. The image quality delivered to all instruments is diffraction limited, which means the fineness of detail that can be seen is exceptional given the telescope's size. Numerous images suggest that the telescope is fully aligned, a part of the Large Magellanic Cloud, which is a small satellite galaxy of the Milky Way. The pictures provide a huge range of view of a dense field of hundreds of or thousands of stars across the observatory sensors. The image's unusual sizes and relative positions show Webb's instrument arrangement in the telescope's focal plane as they each point at an offset parts of the sky. Very recently, NASA released another series of images of the Magellanic Clouds captured using the JWST's mid-infrared instrument. This instrument specializes in mid-infrared imaging and displays MIRI tests at 7.7 microns. NASA has released a side-by-side pair of images showing how better Webb's capabilities are compared to the Spitzer Space Telescope. The JWST is expected to start its scientific observation 6 months after launch, as it will hover at L2 for the next 5 to 10 years. Light from the earliest luminous objects travels so far in an expanding universe that by the time it reaches the Earth, its wavelength will be stretched. That means the earliest universe is observable only in the infrared part of the spectrum, and James Webb is sure to give us glimpses of the early universe that we've never seen before. The most powerful, expensive telescope will look between visible red and mid-infrared light, taking us much further back in time. What it will show is a closely guarded secret, most likely some kind of star-forming region, says McCaughrean. Fascinating, isn't it? As JWST's larger mirror can collect over 6 times the light that Hubble can, having a field of view 15 times the area of Hubble's near-infrared camera and spectrometer, or the NICMOS, its primary aim is to probe the so-called end of the Dark Ages. Can the JWST be able to look back to 100 to 250 million years after the Big Bang? In addition, the JWST is also a general-purpose observatory and will see the birth and assembly of galaxies and hence the origin of life. The scientific operations of the James Webb Space Telescope could lead us to stupefying facts about every phase of the universe's history, from the first dust clouds to our solar system's formation. The much-awaited James Webb Space Telescope is sure to usher in a new era of space observation. From distant galaxies to the newest stars in our neighborhood, there's a lot to look at. Hold your nerves, as new exciting content is sure to pop up very soon. That's all we have for today's episode. Be sure to subscribe to our channel for more enticing videos. Hit the bell icon so that you don't miss out on our uploads. See you all soon with another video. Until then, goodbye.